Hi, this is Professor Sartor, and this video is a continuation of the previous video where I'm working out the problems from the practice test, which covers chapter 3 and 4. So this video will contain questions 11 through 20. The first question says, determine the intervals for which the function is a increasing, b decreasing, and c constant. So what we want to do is take a look at this picture. I want to trace the graph. I'm going to trace the graph moving from left to right. So we start at the furthest left, moving to the right, and trace the graph. As we trace the graph, what we should be thinking about is what is happening to the y values. So looking at the big picture here, starting the leftmost point, tracing, we're asking ourselves what's happening to the y values as we trace along this section. And we can see that the y values are increasing. Then we're going to get to this turning point, and the y values are now decreasing. And then we're going to get to this turning point, and now the y values are increasing again, and we get to this stopping point. So we've now kind of found the sections of increasing, decreasing, and constant. So I'm going to label those. We have increasing on this section, decreasing on this section, and then increasing on this section. And we notice that at those turning points, that's where things changed. So now that we kind of know the big picture of where the increasing, decreasing are, we need to be able to write our answer using interval notation. So we're going to use the x values to say where the function is increasing, decreasing, and constant. The words increasing, decreasing, and constant are describing the y. The where part is the x. We use our x-axis as sort of our map or our directions for where to look on the graph. So I'm going to bring my ruler over here. And for this section that we said was increasing, I want to see where this section starts and stops. So because of that arrow down there, we know that that piece of the graph continues on forever. So this section starts at negative infinity and goes all the way until the x-coordinate on that turning point, which is negative 11. So we can say that this function is increasing from negative infinity to negative 11. And then we also have another increasing section which starts at this turning point. So that starts at an x-coordinate of 11 and goes until this x-coordinate of 18. So also from 11 to 18. And we're going to use parentheses, and we're going to separate our answer with a comma. So we also have a section that is decreasing. That decreasing section starts at this turning point, so that's starting at the x-coordinate of negative 11, and it continues decreasing until this other turning point, which is an x value of 11. So from negative 11 to positive 11, the function is decreasing. And for the last part, part C here, since there are no intervals where the function is constant, we will say no solution for that part. The next question says, for what values of x does the function obtain a relative minimum? Find the relative minimum value. For what values of x does the function obtain a relative maximum? And find the relative maximum value. So we're looking at our picture here, trying to find any relative minimum or relative maximum. Relative minimums and relative maximums are going to be peaks and valleys in the graph. So we can see that right here we have a little valley. So this point right here is going to represent a relative minimum. Let me mark that. So that is a relative minimum because it is a valley. This function doesn't have any peaks in it. It doesn't obtain a highest y value, so it doesn't have a maximum. So let's go through these different answer choices. First it says, select the correct choice below. If necessary, fill in the answer box to complete your choice. The function obtains a relative minimum at, and this is going to be our x value. That is our where part. So x equals 1. The next part says, select the correct choice. If necessary, fill in the answer box to complete your choice. The relative minimum value is, so the relative minimum, the lowest y value is going to be that 0. You really should only, when you do this, you should only type in the value of 1, not x equals 1. Okay, for the next one, it says select the correct choice, fill in the answer box. The function obtains a relative maximum at, I said there is no maximum on this picture, so we're going to fill in there's no solution. And since there is no maximum, there is no relative maximum value. The next example says, determine visually whether the function is even, odd, or neither even or odd. Is the function odd, even, or neither? So let's talk about each one of these vocabulary words. What we need to know is that for a function to be odd, it needs to have origin symmetry. The graph needs to have origin symmetry. And what that means is that you have your origin, which is where the x and y axis cross each other, and origin symmetry is going to have symmetry in these opposite quadrants. So opposite quadrants should have symmetry. To have an even function, you need to have y-axis symmetry. Y-axis symmetry. So when you're looking for y-axis symmetry, your y-axis is the vertical axis, and you're looking for a mirror image over that y-axis. And then neither is the catch-all for everything else. If it doesn't have origin symmetry and doesn't have y-axis symmetry, we put it in the category of neither. So if we take a look at this picture here, let's check for y-axis symmetry first. So we're looking to see if there's a mirror image over this y-axis. And I can see that this little peak here is not an exact mirror on the other side. So this would not be even. Then we're going to look in opposite quadrants. So looking in this upper left and the bottom right, it does look like we have a mirror image here. And looking in the upper right and bottom left, I can see that there is a mirror image there as well. So I would put this in the category of an odd function because it has origin symmetry. The next question says, determine if the function is even, odd, or neither. So an even function is going to have y-axis symmetry. An odd function is going to have origin symmetry. We have a symbolic way that we can represent this, and that is that f of negative x equals f of x. So this is a symbolic representation of what y-axis symmetry would be. The x values are opposites. The x values are opposites, but the y values are equal to each other. So if we think about that in picture form, here we would have an x, opposite of that x, and the two y values being equal to each other. So that would be y-axis symmetry. That's a mirror image over the y-axis. For origin symmetry, symbolic representation would be f of negative x equals negative f of x. So this is where the x values are opposite, negative x and x. The y values are also opposite, one positive, one negative. So this would give you a mirror image over the origin. So what I'm going to do to determine if this function here is f of x equals x to the 13th minus x cubed, I'm going to determine whether this is even or odd based on whether it matches these properties that I've written out, these symbolic representations of y-axis and origin symmetry. If you look at both of them have the symbols f of negative x in them. So that's the calculation that I'm going to do. I'm going to calculate f of negative x. Everywhere I see an x, I change it to negative x. So if I substitute a negative x in, I get negative x to the 13th minus negative x to the 3rd. To simplify, this would be negative x to the 13th and plus x to the 3rd. So that's because negative x to the 13th has an odd number of negatives, so that's going to still be negative. And negative x to the 3rd has an odd number of negatives, so that will still be negative. And because of this other negative, negative and negative become a positive. So once I do that calculation, what I'm trying to figure out is if that calculation equals the same as the original function or the opposite of the original function. So this would be the same. Y-axis symmetry would be the same as the original function. Origin symmetry would be the opposite. So my original function, remember, is x to the 13th minus x to the 3rd, and these are definitely not the same. And we can see that the term x to the 13th, one has a positive, one has a negative, and the x to the 3rd term, one has a positive and one has a negative, so they are the opposite. So because our calculation of f of negative x came out to be the opposite of the original function, we're going to categorize this as an odd function. This question says, sketch the graph of the following function and identify all the properties that apply. And our function is f of x equals x squared. So to sketch the graph, I'm going to graph by plotting points. So I'm going to make a chart. And I will choose kind of a standard set of points that I almost always choose. And that's -2, -1, 0, 1, and 2. Then I'm going to substitute these values in for x. -2 squared is +4. -1 squared is +1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Now I have a set of ordered pairs. -2, 4. -1, 1. 0, 0. 1, 1. And 2, 4. And I can plot those points. -2 and 4 would be here. -1, 1. 0, 0. 1, 1. 2, 4. And I get this picture here, which is a parabola. So I would select answer choice B for the first part. And then in the second part, it says identify all the properties, select all that apply. So let's go through these one by one. A says the function is increasing on the interval negative infinity to infinity. The interval negative infinity to infinity would be this whole x-axis. So this first statement is saying that the function is increasing everywhere. So if I take a look at my graph going from left to right, I have some decreasing on this side and increasing on this side. So this is not a choice we want to select. The function is not increasing from negative infinity to infinity. Let's take a look at the next one. The next one says the function is an odd function. An odd function is going to have origin symmetry. An origin symmetry is when you have a mirror image in opposite quadrants. So for instance, you would look at the upper right-hand quadrant and be looking for a mirror image in the lower left. In the upper left, you're looking for a mirror image in the lower right, which we don't have for this example. So this is not an odd function. The next statement says the function f is an even function. Even functions have y-axis symmetry. So y-axis symmetry is when you're looking for a mirror image over this y-axis. So if we look over the y-axis, we do see a mirror image, so I would select that this is an even function. The next statement says the range of f is negative infinity to infinity. So looking at my picture over here, I can see that my y values only are covering from 0 to infinity. There are no y values on the bottom part of this graph. So that means my range doesn't cover from negative infinity to positive infinity. So I would not select that choice. The next one says the function is a linear function. A linear function is when your graph is a straight line, and this graph is a curve. So I would not select that function, or that statement. The next one says the domain of f is negative infinity to infinity. The domain of this function is negative infinity to infinity because f of x equals x squared is a polynomial function, more specifically a quadratic function. We can also see from our graph that every x value is covered from negative infinity all the way to positive infinity. So I would select the domain is from negative infinity to infinity. The final statement says none of the above properties apply, and we've selected 2, so that one is not part of it. This example says sketch the graph of the following function and identify all the properties that apply. This function is f of x equals absolute value x. So I'm going to use a table. I'm going to choose my standard set of points, -2, -1, 0, 1, and 2. Substitute these values into the function. So I would have absolute value of -2 is +2, absolute value of -1 is +1, absolute value of 0 is 0, absolute value of 1 is 1, and absolute value of 2 is 2. So I'm going to plot my set of ordered pairs that I've just obtained. -2, +2, -1, 1, 0, 0, 0, 1, 1, and 2, 2. And that gives me this V-shaped graph, which is answer choice B. Now let's go through each one of these statements one by one. First one says the domain of f is negative infinity to infinity. And that is true. Looking at the graph, you can see that we have x values that cover from negative infinity all the way to positive infinity. So we have pieces of the graph that cover all the way from negative infinity to infinity. So I would select that property. The next one says the function is increasing on the interval from negative infinity to infinity. Looking at my picture, I can see that on this left-hand side, if I'm going from left to right, my y values are decreasing. So I have decreasing on part and increasing on the other part. This statement says that it is increasing from negative infinity to infinity, which is the whole graph. So I would not select that property. The next one says the function f is a linear function. A linear function would be the graph of a straight line. So because I have a V-shaped graph, I'm not going to select that property. The next one says the range of f is negative infinity to infinity. And looking at this picture, I have y values that are only positive. I don't have any negative y values. There's no piece of the graph down here. So I'm not going to select that property that says the range is from negative infinity to infinity. The next statement says the function is an odd function. Odd functions are going to have origin symmetry, so you're looking in opposite quadrants. I'm looking in the upper right and the lower left, and I do not have a mirror image, so this is not an odd function. The next property says the function f is an even function. An even function is when you have y-axis symmetry. So we're looking for a mirror image over the y-axis, and we do have a mirror image over the y-axis. So we're going to select that this is an even function. The last statement says none of the above properties apply. Since I've selected a few, I'm not going to select that one. This next example gives f of x as a piecewise defined function. A piecewise defined function is when you have multiple equations, and then over here on the side you have some conditions. And the conditions are there to tell you when to use each of those equations. So this equation of x squared should only be used when your x is less than or equal to 0. And this equation of 1 over x should only be used when x is greater than 0. We have 3 parts to work through. Find f of negative 6, f of negative 5, and f of 5. So part A, f of negative 6. This notation is telling me what the x coordinate is. This is telling me that x is equal to negative 6. So then I'm going to go over to my piecewise defined function, and I want to go to the conditions and decide which equation to use. Since x is negative 6, I want to use this one right here. Negative 6 is less than or equal to 0. That is a true statement, and I'll use that equation to work it out. So I'm going to substitute that negative 6 into the equation for x squared to get the answer of 36. Part B, f of negative 5. So in my conditions, negative 5 is less than or equal to 0. So once again, I'm going to use that first equation to work this out. Negative 5 squared would be 25. Part C, find f of 5. So this time my x is 5 and 5 is greater than 0, so I'm going to use the second equation this time to work out the solution. 1 over 5 is 1/5, and that would be the answer for part C. This next example says use the graph of a known basic function and a combination of horizontal shifts, reflections, and vertical shifts to sketch the function. Our function is g of x equals negative x squared minus 2. So our first thing we need to do is take notice of the power of the 2 right there. That's going to tell us what our basic function is. I usually call it base function. So our graph will have a similar picture to a parabola like this. So because our basic graph or base graph is y equals x squared, we know the basic shape that it will be in. Then we're going to analyze that equation to see what transformations we have. So I've got a transformation right here of -2 and a transformation right here of this negative. Those are things that are going to change what the original graph looks like. So let's start with that -2. That -2 is a vertical shift. I know it's a vertical shift because I have a few things memorized. Shifts always happen when you have adding or subtracting in your equation. So because I have a subtraction here, I know it's a shift. But I know it's a vertical shift because of where that adding and subtracting occurs. So because this subtracting happened away from that squared, I know that it's a vertical shift. If the adding or subtracted was inside of that squared, then it would be a horizontal shift instead of a vertical shift. And then that -2, the fact that it's a minus tells me that I'm going to go down 2 units. Minus for down, if it were plus, I'd be going up. Let's talk about the other transformation, which is that negative. That negative is a vertical reflection. So I know it's a reflection because of the negative. Anytime you have a negative multiplied onto your function, it's going to be a reflection. And then just like I talked about in the shift, the location of that negative makes a difference of whether it's vertical or horizontal. So because that negative is outside of the squared, it is a vertical shift versus a horizontal shift. So let me show you the difference. So we have -x squared, which is a vertical reflection. If you had -x squared like this, it would be horizontal. So this one is vertical, and this one is horizontal. So now we're going to graph this equation with this knowledge. So what we do is we start with y equals x squared. So that's a graph that just quick sketch looks like this. Then we are going to do the vertical reflection. So if I were to throw in that negative, what that does is it gives you a mirror image going over the y-axis. And then if I throw in the last transformation, which is the -2, that is going to shift all the points down too. So instead of crossing at the origin, I'll cross at -2. So we get this, get this picture here. So I'm going to draw the final graph here on the grid. It will look like this. And that is our graph drawn with the idea of transformations. This example says, use the graph of a known basic function and the combination of horizontal and vertical shifts to sketch the function. Our function is g of x equals the absolute value of x minus 2 minus 3. So I'm going to start by recognizing those absolute value bars in the equation. Those absolute value bars tell me what the basic graph looks like. And in fact, this question gave us that information already. Y equals absolute value of x has this picture over here. This is the absolute value graph. And then we want to analyze the transformations in the equation. So in my equation, I have a minus 2 and a minus 3. Those are my transformations. The minus 3 and the minus 2. Both of these are adding and subtracting. So both of these are going to be shifts. And then we want to determine what type of shifts they're going to be. And you can tell whether they're going to be a horizontal shift or a vertical shift based on the location, whether it's inside the absolute value or outside the absolute value. So inside, like the minus 2, is the horizontal, and outside, like the minus 3, is a vertical shift. And then we need to figure out which direction. The minus on the 2 tells us that we're going to go right 2. The minus on the 3 tells me that we're going to go down 3. So we start off with our basic graph, the y equals absolute value of x. That is the V-shaped graph. And then if we draw in our transformation, our horizontal transformation, y equals absolute value of x minus 2, I'm going to go to the right 2, shift every point to the right 2, and then the last transformation, which is minus 3, we're now going to move all of those points down 3 to right here. Looking at my answer choices, I can see that answer choice D matches that. This question says, use the graph of the known basic function and a combination of horizontal and vertical shifts to sketch the function. Our function is h of x equals the square root of x minus 1 plus 4. Now, even though this example gives us the picture of the basic graph, I want to make sure you know how we get that picture. So I'm going to make a table. I usually choose like a standard set of points, -2, -1, 0, 1, and 2, but I know about square roots. Taking the square root of negatives would give you I, and there are certain numbers that are easy to take the square root of. For example, square root of 4 is 2. So I want to make sure this time, instead of just choosing any points, I'm going to choose some numbers like 0, 1, 4, and 9 to make sure that it's easy for me to work out the square roots of those numbers. So the square root of 0 is 0, the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So if I put that on my picture, 0, 0, 1, 1, 4, 2, and 9, 3 gives me that picture right here. And if you have trouble remembering what this picture looks like, this is actually half of a sideways parabola. Okay, so now that we feel confident in knowing what this base function looks like, let's take a look at the transformations that we have. So I see in my transformations a +4 and a -1. So the +4 and the -1 are both adding and subtracting, so they are both shifts. The +4 is on the outside, so it's a vertical shift. And the -1 is on the inside of the radical, so it's a horizontal shift. The +4 being vertical is going to go up. And the -1 is going to go right. The minus tells me it's going to go right 1 and up 4. So I'm going to erase my picture that I drew over here so that I can sketch all the transformations. So we know that y equals square root x has that half of a sideways parabola picture. And then I want to do the transformation of moving to the right 1. So moving to the right 1 would give us this picture. And then moving up 4 would give us this picture here. So this is y equals square root x minus 1, and this one is y equals square root x minus 1 plus 4. So looking at my choices, I would choose option B for this example.